In this video, let's focus on the second step of our exogenous process, and that's mass wasting. So mass wasting is defined as the downslope movement of rock, soil, and other debris due to the pull of gravity. So there are different factors which may be involved in mass wasting. So first, speed. So you may know mass wasting as like a landslide, and if you imagine a landslide, it's usually fast, quite deadly, but there are actually different forms of landslides or mass wasting, and they have different speeds, which I will show you later. Next, type of material. So the type of material involved in the mass wasting event will influence how fast the mass wasting event will be. Next, the nature of movement, if there has been a cause or trigger due to the movement. The presence of water. So usually if there is a high presence of water downslope, that would mean it would be a fast mass wasting event. Next, we have your soil cover. So is there an involvement of soil or a large amount of soil in the mass wasting event? And then finally, we also have your geologic features. So what are the geologic features involved? And finally, other triggering events as well will all factor in a mass wasting event. Okay, so let's discuss a few things. First, angle of repose. So angle of repose is a technical term for the highest angle that the side/slope of a mound of unconsolidated sediments will achieve under the influence of gravity. So just to simplify this. So imagine a clump of sand. So sand itself, let's make a hill of sand. There will be a maximum angle in which you can make a hill of sand. You can't make a hill of sand which is very steep because there's only a certain angle, a maximum angle that the sand can achieve, and that's called the angle of repose. So that's the maximum angle or the highest angle that a clump or like a mound of materials can achieve. So scientists do study this, if what is the highest angle of the materials once they are clumped or arranged into a mound. So fine sand will have a 35-degree, coarse sand 40-degree, and angular pebbles will have 45. So this just shows you that if the materials, the unconsolidated materials, have angles, it will create a steeper slope. Then steeper slope actually trigger fast mass wasting event. There is a higher tendency for materials to undergo mass wasting if there is a steep angle. So we can see here that angular pebbles will most probably go through a mass wasting event compared to the fine sand, which has a smaller angle. Okay, so next we have already mentioned this. You have your water. So moist sand will be able to achieve steeper sides. So when water is mixed with the soil or the sand, it will create a higher angle of repose, and that will encourage further mass wasting. Then there will also be introduction of other factors. You may also have surface tension, cohesion, and adhesion. Okay, so because of these additional factors, it all factors in creating a higher angle of repose, thus encouraging the mass wasting event. Then once too much water is achieved, the grains will tend to slide past one another and become more fluid. So if there is enough water, it will encourage a steeper angle of repose. If there's too much, then it will lessen the angle of repose. Okay. Next, you have your soil cover. Okay, so that also depends on what type of minerals is within the soil, which is involved in mass wasting. So clay materials, if there is a high level of clay materials in the soil cover, that will affect the possibility of mass wasting event. Okay, next you have your geologic features. You have certain structures that you have to look out for when looking at steep sides. So you have joints and faults. So joints and faults are the weak parts of your geologic feature. Okay, so the joints are like the cracks in the rocks itself. So if there is large joints in the rock itself, that could be where the weathering may happen or might break, or where the rock itself may break apart. So here you will see that the rock itself has small cracks already, or joints, and if water goes in those cracks and then you have a triggering event, it may result into mass wasting. Next, you have a bedding plane. So bedding planes are a zone of weakness in a rock that may increase the potential of slide. So you will see here that there is a slope here, because this is quite technical, but this rock used to be horizontal, but now it's in a vertical position, diagonal position. So since it's in a diagonal position, the bedding plane is now diagonal. So that diagonal area may have a zone of weakness within it, that when a triggering event happens, this will be the area where the rock itself will break apart and undergo mass wasting. Okay, so triggering events, like I have mentioned, may involve earthquakes, excessive rainfall, volcanic eruptions, and so forth. So human activity may also be a triggering event as well. Okay, so we'll be showing you the different types of mass wasting and also showing you speed as well. So we have mass wasting, which is the slowest kind here, the slowest speed in this area. And then as you go towards the right of the diagram, you have faster moving mass wasting events. So soil creep and solifluctions are quite slow. So solifluction is very slow to the point that grass is already growing in them. So it's not visible unless you are observing it closely for a long period of time. Soil creep is also a slow type of solifluction, of mass wasting, but the difference is soil creep happens in dry conditions while solifluction happens in wetter conditions. Okay, you have your slump, earth flow, debris slide, debris flow, rock fall, and then mud flow. So the fastest among all happens in wet conditions, which is mud flow, and also rock fall as well. So mud flow will happen in wet conditions, so very fast, very dangerous, and then you have your rock fall, which is also quite fast and happens in dry conditions. Okay, so in this part, I'm going to show you a video which is going to give you examples of mass wasting, and then we'll try to classify them together.
How high am I? That's just all the debris in front of it.
Son of a bitch.
Holy cow.
Okay, so let's try and classify the examples that we have shown you. We have 3 examples of mass wasting events in the video. So first, if you can recall, it's like a slow movement where people can even walk on the mass wasting event. So that could be classified as either here. So it can be classified as earth flow. So it's not as slow as the soil creep or the soil deflection, but it could be either slump or earth flow. So we can't really tell if unless we observe it or record the details closely, but it could be either slump or earth flow. So in the second one, do not imitate the guy there. If you see falling rocks on a steep side, run. It's not safe. Do not take a video. Just take cover. Okay. So that could be either here. It could be either debris slide or rock flow already. Or actually, it has been raining, so that may have caused that fall. So either of these 3, debris slide, debris flow, or rock fall. So again, we can't really tell unless we closely observe the scenario. And then finally, the last one is obviously mud flow. So I think the men have dug a trench in order to control the mud flow, because mud flow, if not controlled, could pose several risks. So if you have been listening or watching the news, the Lahar movement in Albay has buried houses, and that's actually a type of mass wasting event triggered by an extreme weather. So mud flow is the classification of that mass wasting event. So it can pose risks, especially if it's in a large scale. Okay. So I have already shown this slide before in our rock discussion or rock module. So just showing you because again, rocks are still part of the geomorphic process. So distance traveled affects class size, class shape, and class sorting. So when steep slope, so if there is mass wasting or erosion in steep slope, it will create poorly sorted and angular types of rocks or particles. If there are strong currents present in the mass wasting or erosion process, it can transport large pieces or large rocks. If it's weak, you will have fine-grained materials involved in your mass wasting or erosion event. And then other geomorphic agents that we have not discussed, we have your wind and glaciers as well. So wind can transport or erode fine materials. Glaciers are capable of both large and small particles. Okay, so that would actually cover our exogenous event. We only focused on the weathering and mass wasting and some parts of erosion, but we won't discuss transportation and denudation anymore. Okay, so that's it for the exogenous. We'll be discussing endogenous processes in our next video. That's all. Stay safe. Bye.